Okay, let's go through conversion practice, beginning with reviewing these. How many significant figures in a conversion factor? If it is two different measuring systems, metric and English, then it is not infinite significant figures. Sometimes, not always, we will give you the hint with these wavy equal signs, but we have to understand this is an approximation because the real number goes on forever like pi. So we rounded it to three significant figures for your amusement and ease of calculations, I suppose. The two metric units, being of the same measuring system, have infinite significant figures. Therefore, if you're converting between systems, this does influence how many sig figs in your final answer. If you're staying in the same measuring system, whether it be two metric or two English or whatever units, then it does not influence how you round your final answer because it's infinity significant figures. All right, now onward. Let's do some calculations. So, converting from grams to micrograms. This is a one-step conversion. I know that because one of the units is a base unit. So you do what we always do. You write your given, 1.75 grams in this case. Multiply it by a conversion factor. It's going to equal the unit you want, micrograms. Now you got to memorize microgram means 1/1,000,000th of a gram. Therefore, the number million is involved here somewhere. But we'll get to that in a sec because in order to figure out where you put the million, you got to figure out where your units are first. So that means put gram on bottom so that gram can cancel gram. Put microgram on top so that it can be in the final answer. And now you put your numbers in the right place. So if micro means 1/1,000,000th, the number million belongs here somewhere. And the big number goes next to the small unit. So I'm going to put the number million here. I can either put that or I can put 1 times 10 to the 6th, which is a million. So either way you write a million, put a million next to micrograms because that is smaller than a millionth of a gram is smaller than a gram. So the big number goes next to the small unit and automatic 1 goes next to the other unit, because that's how many micrograms are in 1 gram. And then this is telling us to take this times a million to give this. And that would be 1.75 times 10 to the 6th micrograms. That's just what you get when you get this times a million. Infinite sig figs, 3 sig figs, 3 sig figs. Box our answer. Note it has the correct units. Okay, we move on. 1.6 meters equals how many millimeters? You might know that that's 1,600 meters off the top of your millimeters off the top of your head, but it doesn't matter. You got to show your work. Write that given 1.6 meters times how many conversion factors? Just one, because one of the units in our given is one of our units in the original question. Let me phrase it that way. Is a base unit. So we're going to do that. We want millimeters. Put millimeters on top to make sure it's in the final answer. Put meter on bottom. That way meter cancels meter. And then what we do next is we look at what numbers we're going to put where. Milli means 1/1000th, so the number 1,000 goes in here. The big number goes next to the small unit. 1,000th of a meter is smaller than a meter, so this is the smaller unit. So we put 1,000 next to it. And we put one automatic 1 next to the other one. So 1 meter is 1,000 millimeters. So in other words, it's saying this times 1,000 is 1,600 millimeters, as I said before. And of course, you got to put that in scientific notation. So it's 1.6 times 10 to the 3rd millimeters. Why did I round it that way? Because we have 2 sig figs here, infinite sig figs here, therefore 2 sig figs here. All right, onward. 87 deciliters is how many milliliters? This is a two-factor conversion because this is starting with not a base unit and ending with not a base unit. So if there's no base units, it's minimum 2 factors. So 87 deciliters times that, and then another conversion factor is going to equal our answer in milliliters. So let's look at this. Deciliter goes on bottom, so deciliter can cancel deciliter. Milliliter goes on top, so milliliter can be the final answer. And then what goes here? Well, remember, you convert from the derived unit to the base unit, and then from the base unit back to the other derived unit. So in other words, this is some flavor of a liter, this is a different flavor of liter. So you got to convert from deciliter to liter, and then from liter to milliliter. So that's why there's liter on each of these, because you convert from deciliter to liter, and then from liter to milliliter. So here, deci means 1/10, so you got to put the number 10 in here. Deciliter is smaller than a liter, so we're going to put the number 10 down here. Big number goes next to the smaller unit, because 1/10 of a liter is smaller than a liter. Here, milli means 1/1000th, so we're going to put 1,000 on top, because the smaller unit happens to be on top. And then 1 goes on the bottom. Sometimes people, for some reason, think that 1,000 always goes on top. No, it doesn't. It only goes here because the smaller unit happens to be on top. Anyway, having done that, we say this divided by 10 times 100, or sorry, times 1,000. Now that would be the same as times it by 100, or making 8,700, but let's just do this with a calculator just for clarity. Divided by 10 times 1,000, 8,700. So 8,700 milliliters. 2 sig figs, infinite sig figs, infinite sig figs. So we got to have 2 sig figs here. So that's going to be 8.7 times 10 to the second milliliters. 2 sig figs. I don't know why I just said second. That should be third. All right. Now, that said, should point out this does have 2 sig figs here. However, bigger than 1,000, you better be writing scientific notation. All right. Now, onward to this one. 45,887 micrograms times, okay, this is going to be multiple conversion factors because there's no base unit. And it's going to give something in milligrams. So we got micrograms on bottom, so microgram can cancel microgram. Milligrams on top, so that milligram can wind up in the final answer. We're going to convert from microgram to gram to milligram. We want to convert from this to the base unit and from the base unit to our final unit. So that's why I'm going to put gram in these blank spaces here, because you got to go from microgram to gram and then from gram to milligram. Micro means 1/1,000,000, so you got to put the number million next to the small unit, and a millionth of a gram is smaller than a gram, so the number million goes down here. You can either put 1 million with 6 zeros, or you can put 1 times 10 to the 6. Either one's fine, I don't care. And then put an automatic 1 next to the bigger unit. Same here, 1 gram is much bigger than a milligram, which is 1/1000th of a gram, so you put 1,000 next to the smaller unit. So we're going to take this, divided by a million, times 1,000, and that's going to give our answer. So let's do that. So divided by a million times 1,000, same as divided by 1,000, but I'll show you. 45,887 divided by a million. So that means either divided by 1, 2, 3, 4, 5, 6 to give that, or you can get the exact same thing by doing 45,887 divided by 1 times 10 to the 6th, because that's what a million is. See, same number. Anyway, once you've done that, you then times it by 1,000, and you've got 45.887. You could use scientific notation, it's fine. It'd just be 4.5887 times 10 to the first. But you notice there are 5 sig figs, infinite sig figs because they're both metric, infinite sig figs because they're both metric. And then this is going to be, since this is 5 sig figs, this is 5 sig figs. All right, now onward. These are all metric to metric conversions. Now let's do a conversion that is metric to English. So heaviest man in the world, maxed out at 594.8 kilograms, or at least his heaviest reading. So that's our given, 594.8 kilograms. It's asking, what is it in pounds? So we take the information given to us, kilogram is that many pounds, and we're going to convert to pounds, with that being the standard abbreviation for pounds. So we need pounds on top, that way it's in our answer. We need kilograms on bottom, that way kilograms cancel kilograms. It says 1 kilogram is 2.20 pounds, so 1 kilogram is 2.20 pounds. So the math is telling us to take this number and times it by 2.20. So that's 594.8. Check your right answer. Yeah, okay. Times 2.2, 1,308.56 pounds. Now, don't box that as your final answer, because this is not both metric units. This is a metric unit here. You're converting to an English unit, so this is a conversion factor with mixed units, which means it is not infinite significant figures. It's limited to the number of things. In fact, it's the very same one that we talked about up here. Don't pay attention. Don't worry about that. This is like an infinitely accurate 1 kilogram is equal to approximately more or less 2.20 pounds. So this is 3 sig figs. This is 4 sig figs. This is 3 sig figs. You better round to 3 significant figures. So that's going to become 1,300 and, so you round right here, 10 pounds. And then, of course, you want to make that scientific notation, which would be 1.31 times 10 to the third pounds. There we go, because that number's over 1,000. We have to write that as scientific notation. So onward we go. That many inches converted to centimeters. All right, we actually have a conversion factor right up here that we can use for that. So we write our given 0.003 inches. We've got a direct conversion factor, so we can just do it all in one piece. Times conversion factor, inches on bottom so that it cancels, centimeters on top, because we can go straight from inches to centimeters, so we can put it all together in one conversion factor. It says 1 inch is 2.54 centimeters, so 1 inch is 2.54 centimeters. This is English, this is metric, mixed systems. You would know, therefore, this is not infinity significant figures. So you're going to be limited by the sig figs of this. Now, it's telling you, however, take this number times by 2.54, so we shall do that. 0.003 times 2.54. And you get that. 0.00762 centimeters. So what is that going to look like? Well, first of all, one significant figure, 3 significant figures, you better round this to one sig fig. That's 0.007 centimeters. Sorry, 0.008 centimeters. Because that 7 is next to a 6, so it rounds up. That's one significant figure. Leading zeros are not significant. And then if we want to do that scientific notation, that is 8 times 10 to, let's see, 1, 2, 3. We've got to move the decimal 3 times. It's in tiny numbers, so we make that a negative exponent. 8 times 10 to the negative third centimeters. All right, there we go. Onward, 88 pounds is how many grams? Oh, how are we going to do that? Okay. We have something that tells us we can go from pounds to kilograms. So let's use that. Pounds to kilograms. You can take 88 pounds and we can convert from pounds to kilograms, and then we convert from kilograms to grams. So we're going to go pound, kilogram, gram. That's our strategy. So I put pound on bottom so that it can cancel, and we're going to from pound to kilogram. And then we're going to go from kilogram to gram. That's what it looks like. Pound to kilogram is here, and then kilogram to gram is right here. So pound cancel pound, kilogram cancel kilogram gives gram for the answers, which is what we want. And then we just go look up here. 1 kilogram is 2.20 pounds. So 1 kilogram is 2.20 pounds. And then we should all know that kilo means 1,000. So 1 kilogram is 1,000 grams. The reason the number 1,000 goes up here is because gram is smaller than a kilogram, so the big number goes next to the small unit. Okay, the number 1,000 doesn't always go on top, but just by chance it has for the examples that we've used here. Now, next, onward. What is this saying? Take this, divided by 2.2, times 1,000, and you'll get your answer. So let's do that. 88 divided by 2.2 equals times 1,000 equals. Yes, break it up in small steps like that, or you're going to have an issue with wrong order of operations. All right, so that is 40,000 grams. Now we need to round that for correct significant figures and put that in scientific notation. First of all, scientific notation for 40,000 grams is 4 times 10 to the 4th, because you have to move the decimal 1, 2, 3, 4 times. So it's 4 times 10 to the 4th. However, notice this is 2 sig figs, this is 3 sig figs, this is infinite sig figs. If you write 4 times 10 to the 4th, that's just one significant figure. That's not good. So what we need to do is take this, first of all, write it as scientific notation, 4, and then in order to make it 2 significant figures, make it 4.0 times 10 to the 4th grams. We can box that for our answer. All right, so let's get ready to move along then. So next one, this one. That many centimeters is how many miles? How are we going to do that? Okay, we can do centimeters to miles? No. Where are you going to find that on here? It doesn't tell you anywhere how many miles are in a centimeter, centimeters are in a mile. You could, however, do this a couple of different ways. You could go from centimeters to inches to feet to miles, you could do that series of conversions, or you could convert from centimeters to meters to kilometers to miles. And there's probably some other ways, but these are just two that quickly pop into mind as I'm looking at this paper. Whatever works for you, you can do for you. But here's a couple that I recommend, and I guess I gotta pick one to show you, so I guess I'll do the first one. But if you do the second pattern, you'll be fine. It doesn't matter which way you do it. As long as it's legitimate, you're fine. So just for kicks, I'll do the top one. Centimeters, 88,924 centimeters times. And we're going to go from centimeters to inches. So I put centimeters on bottom so it cancels, and then inches up top. And then another conversion factor. We're going to go from inches to, our strategy says inches to feet. Okay, so I'll put feet up top. That way inches cancel inches. Then another conversion factor. We're going to go from feet to miles. So I'm going to put feet on bottom and miles on top. So why am I doing, and where do we get this information? Well, luckily it's provided right here at the top of the paper for you. That's how many inches are in a foot. That's how many miles or feet are in a mile. So we can go with that. So that's our units. Centimeter cancels centimeter, inch cancels inch, foot cancels foot, leaving miles. So you get an answer in miles. So how are we going to set this up? Well, let's go look. It says 2.54 inches is equal to 1 centimeter. Sorry, 1 inch is 2.54 centimeters. I said that wrong. But this is what it says up there. 1 inch is 2.54 centimeters. 1 foot is 12 inches. And 1 mile is 5,280 feet. Right, so that's how you'd set that up. And then what you do is you just go through and you calculate it on the calculator. So 88,924. And we're going to do divide by whatever's on bottom times by whatever's on top. So divide it by 2.54, divided by 12. Notice how I'm doing it one step at a time. It's important. If you try to do this all at once, you're going to mess up and get the wrong order of operations. So you divide, push equals, divide, push equals, divide, push equals. There's nothing on top, I guess, this time. So in this one particular case, we're not multiplying by anything. Anyway, divide by 5,280. And that's what we got, 0.552548. How many sig figs? That's 5. That's 3, because metric and English, so not different measuring systems. These are both English, so this is infinity sig figs. These are both English, so that's infinity sig figs. So 5 and 3, we better round to 3. So what's this rounded to 3 sig figs? 0.55, and then that 2 is next to 5, so it becomes a 3. 0.553. So 0.553 is our answer. All right, so let's move that one along. So looking at this here, how many seconds are in a minute? I know you know that there's 60 seconds in a minute, but if you write 60, you're getting no credit at all. You've got to show the conversion. 1.0 minutes, yes, you can use the official abbreviation MIN, times a conversion factor with minute at the bottom so that it cancels, and then seconds. You can use that or that. You can use either abbreviation for seconds. It's fine. And then that's going to minute cancels minute to give seconds for your unit. So you should know that there are 60 seconds in a minute. You can put that in the conversion factor because that is a place where we can have it. At that point, you take 1.0 times 60 divided by 1 equals 60 seconds. Now, this is two significant figures. These are both time units, so it's infinite sig figs. So you better have 2 sig figs here. 60 is just 1. If we put a decimal, now it's 2 significant figures. So 60 with a decimal point, seconds. Onward, 6.3 hours. Let's write down our given. Times. And then we got to do hours on bottom for sure. And we're trying to get to seconds. Now, we don't know how many seconds are in an hour. So here's what we're going to do. And by the way, I should mention it's not on your chart either. So you're not allowed to look it up and use it. You can only use what's on this chart. So if you don't see from seconds to hours on this chart, sorry, you can't use it. All right, so, and that goes for here too. If it was up here, you could use it, but if you don't happen to know how many seconds are in an hour, sorry, you can't use it. But you do know that we assume everyone knows that within an hour there are minutes. And 1 hour is 60 minutes. And then so, okay, if we can go from hours to minutes, then we can go from minutes to seconds. So 1 minute is 60 seconds. So what does that leave us with? 6.3 times 60 equals, times 60 again equals 22,680. Okay, fair enough, but that's 2 sig figs. These are both time units, so that's infinite. These are two time units, so they are also infinite. So 2 sig figs, this better be 2 sig figs. So first of all, scientific notation, this is going to be 2.2, or is it? 2.2, that 2 is next to a 6, so 2.3, and that's it, leave it. Because that's your 2 sig figs right there. So 2.3 times 10 to the, what would it be? 1, 2, 3, 4, times 10 to the 4th. And by the way, if you don't believe me, let's make that scientific notation. There, 2.268. Round that to 2 sig figs, it's 2.3 times 10 to the 4th. All right, so by the way, don't forget though, it's asking how many seconds. So let's not forget to put our unit on there. There you go, that many seconds are in 6.3 hours. Now you're going to calculate how many seconds in the entire history of the universe, which is 1.37 times 10 to the 10th years. Let's write that down, 1.37 times 10 to the 10th years. Okay, here's what we're going to have to do. It tells you from years to days. So we're going to go from year to day. And then once we have the number of days, we can go to hours, and then minutes, and then seconds. All right, so that's going to be our path to find out how many seconds in the entire history of the universe. So let's get that conversion factor going. Year on bottom so I can cancel, and then days. And then multiply it by another conversion factor from day to hour. So we'll put day on bottom, hour on top. Day is on bottom, that way day can cancel day. Then we'll put hour on top so we can cancel, and then minutes. And then put minutes on bottom so we can cancel, and then seconds. So year cancels year, day cancels day, hour cancels hour, minute cancels minute, leaving seconds as your answer. Now let's fill in the numbers. 1 year is, on average, over the course of many, many years, because there's leap days and whatever, 365.242. And then hopefully we all know that 1 day is 24 hours, and 1 hour is 60 minutes, and 1 minute is 60 seconds. This is approximate. So I know time units would tell you that's the same measuring system, but to be technical, it's actually, this is a rounded off number. But nonetheless, we gave lots of sig figs, so it's not going to really affect much because this is only 3 sig figs. This is infinite sig figs because it's both time units. Infinite sig figs because it's both time units. Infinite sig figs because it's both time units. Yes, I'm aware technically it's not exactly 24 hours to a day, but we'll just say it is. Anyway, that means we're going to round to 3 sig figs for our final answer. So don't forget parentheses around your scientific notation. So I just push parentheses button and then 1.37 times 10 to the 10th. And let's do exactly what it says, times 365.242 times 24 times 60, and then times 60 again. And we get that. I said 3 sig figs, right? So because of this, 3 sig figs. So 4.32 it is, times 10 to the 17th. Don't leave out that scientific notation portion. So 4.32 times 10 to the 17th seconds in the entire history of the universe. All right. Onward then. Now for density. What is the mass of that many liters of alcohol if it has a density of that much? Okay, remember, density equals mass over volume. You're not allowed to use it. Don't even try. So instead, you look at the units. You have liters, grams, and milliliters, and there is no way that, okay, mass, you see in grams here, so you know you're going to answer in grams because it asks for mass and you see grams. Okay, respond with what you're given, grams. However, that means you need milliliters to cancel out and liters, but they can't cancel each other out because they're not the same unit. So that means you either need to convert this to be grams per liter or convert this to be milliliters. And it's probably easier just to convert this to milliliters, though it's not much difference to make this liters. So we'll just convert this to milliliters. So 63.2 liters times, we'll put liters on bottom, milliliters on top, and then milli means 1/1000, so we put 1,000 next to milliliter because a thousandth of a liter is far smaller than a liter, so the big number goes next to the small unit. So this times 1,000 divided by 1 tells you how many milliliters. That's 63,200, but whatever, I'll just do this to show. All right, so 60,200 milliliters. So here's the thing. If it's 63,200 milliliters, we can now take milliliters, cancel milliliters to give grams. How? Let's take 63,200 milliliters. And if we, sorry, I shouldn't have used that units. I shouldn't have used the number. I should have gone with units first. But if we have milliliters and we times it by grams per milliliter, then we can have milliliter cancel milliliter giving grams for our answer. Okay, we need to focus on units first. Once we see that milliliters can cancel with the milliliters on bottom to leave grams, now I can plug in the numbers. Milliliters has this number attached, that's why that number's there. And here, density tells you the mass of 1 milliliter or the mass of 1 cubic centimeter. So it's saying the mass of 1 milliliter is 0.790 grams. So there's an implied 1 here. So that this number stays with the grams, so 0.790 and then 1. So the mass of 1 milliliter is that many grams. So anyway, with milliliters canceling milliliters, we now get an answer in grams, and let's go ahead and do that. So this times 0.790. And we get that. 49,928. So 49,928 grams. But don't even think about writing it this way for your final answer because you got to convert that to scientific notation. So that's 4.9928 times 10 to the, what is it? 1, 2, 3, 4. And it's a big number, so positive 4. So it's that many grams. And then we got to round for sig figs. This is 3 sig figs, because this came from 3 sig figs right here. So we have 3 sig figs here and 3 sig figs here, so we better round to 3 sig figs here, which makes it 4.99 times 10 to the 4th grams. 4.99 because the 9 is next to a 2, and so it means it rounds down. All right, so that's what that looks like. That's the mass of that much alcohol. Onward. The volume of pure sulfur weighing 130 pounds. Okay, so look, we told you how many pounds per kilogram, or we gave you another way of converting pounds to kilograms. Instead of 1 kilogram equals a certain number of pounds, now we have a certain 1 pound equals a certain number of kilograms. Fair enough. If you were to use this other conversion, it may be slightly different, but it'd be close enough that we'd be fine with it on a test. So the volume of pure sulfur weighing 130 pounds. If you want the volume, you're going to be answering with cubic centimeters, which means gram needs to cancel with pounds. So this means you either need to convert this to pounds or convert this to grams. Let's convert this to grams. 130 pounds times pounds on bottom, so it cancels, and kilograms on top because that's what we're given. And then let's go from kilograms to grams because we need to convert this to grams so that it can cancel with this grams here and leave us cubic centimeters for volume. So 1 pound is 0.454 kilograms. And then kilo means 1,000. So there's 1,000 grams in a kilogram. How do I know that? Because kilo means 1,000, and you put 1,000 next to the small unit, and 1 gram is certainly smaller than 1,000 grams, so the number 1,000 goes next to grams because it's the smaller of these two units. And there's an implied 1 right here because 1 kilogram is 1,000 grams. So we take this times this times this to tell us what pounds is in grams. So 130 times 0.454 time, well, actually, let me show a good example of just one at a time where you might make a mistake. So this times this equals this, and then times 1,000 is 59,020. Now, yes, I know you could round to 2 sig figs here, but don't save your rounding for the end. Okay, don't round anything until you're done. All right, so that is the number of grams. So we need to take grams and grams per cubic centimeter and figure out how to make it cancel to give cubic centimeters. Now, first of all, if you want cubic centimeters for your answer, this needs to be on top. So we're going to flip this units around. We're going to put grams on bottom, cubic centimeter moves to the top. Therefore, if we have grams times cubic centimeters per gram, because if you flip this upside down, grams per cubic centimeter, it becomes cubic centimeters per gram. So this flipped upside down becomes this. That allows gram to cancel gram to leave cubic centimeters. So let's do that. What number has gram attached? It's this one. So 59,020 grams times, and let's take that cubic centimeters per gram. That's here. Notice the 2.07 is for the grams because 1 cubic centimeter is a mass of 2.07 grams. So if, let's see, oh yeah, 2.07 grams, 1 cubic centimeter. Sorry, slightly messy, but you get the idea. If the gram moves to the bottom, that 2.07 needs to follow it to the bottom. So what that means is you're going to have this times 1 divided by 2.07. So this, 59,020, let's start with fresh, divided by 2.07. It's that. All right, now, anyway, 28,512. Let's see, oh, sorry, cubic centimeters. Actually, sorry, what I should be doing is writing out the whole thing and saving the rounding for later, though I know we certainly are not going to be having that many significant figures. 12.07729, etc. I'm sure there's more decimals not displayed on the screen, but that is the volume in cubic centimeters. So first of all, we're going to convert that to scientific notation. You can do this manually, 2.8512 blah 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 times 10 to the 4th power, because you got to move the decimal 1, 2, 3, 4 times to make it between 1 and 10. So in order to figure out how to round it, look at all conversion factors you used and see how many significant figures. Also look at your givens. So this is 2 significant figures, this is 3. This conversion factor only has 3 sig figs because one's metric, one's English. These are both metric, so that's infinite sig figs. So what we're looking at is 2 sig figs, 3 sig figs, 3 sig figs. This was just an intermediate answer along the way, don't worry about it. So 2 sig figs is the smallest number of sig figs I see anywhere. So we better round this to 2 significant figures. So this becomes 2.8, nope, this 8's next to 5, 2.9 times 10 to the 4th cubic centimeters. There, like that. Just to repeat what I said earlier, because I think part of that might have been cut off earlier in the video. This is the rounding was to 2 sig figs because this is 2 sig figs, this is 3. This is an intermediate form. We avoided rounding because it wasn't the final answer. And this is 3 sig figs. So we look at all the numbers we worked with. We see this one as the least, so that's why it's 2 sig figs. So anyway, moving on. What's the mass of that many gallons of alcohol with a density of that many grams per milliliter? 1 gallon equals that many liters. So we're going to convert this to milliliters. That way it can cancel with the milliliters here to leave us the mass in grams. So 63.2 gallons. And we're going to convert from gallons to liters. Let's put gallons on bottom so gallons cancel gallons and go to liters because we got this. And then we're going to go from liters to milliliters. That way milliliters can cancel with this to leave us with grams. So why did I put gallons on bottom? So we can cancel. Why did I put liters up here? Because we can convert from gallons to liters. And then why did I put liters down here? So liters can cancel, so it's not the final answer. And why did I put milliliters here? Because that's what I'm trying to get for my final answer is milliliters, or at least get this into a form that can cancel with this. So 63.2 gallons. Let's see, 1 gallon is 3.78 liters approximately. So 3.78 liters is 1 gallon. And then 1 liter is 1,000 milliliters because milli means 1,000th, which means the number thousands involved. And you put it next to the smaller unit, and milliliter is smaller than a liter. So there we go. So it's this times this times this. So 60, oops, let's put this in regular mode. Okay, 63.2 times 3.78 equals times 1,000 equals that. And let's put that in scientific notation. 2.3886 times 10 to the 5th. Though I suppose it's not a final answer, so if you to put it in regular notation of 238,896, make sure you label it as milliliters either way. That gives you something you can work with. Now, if you have milliliters and grams per milliliter, oh look, if you times them by each other, milliliters cancel milliliters and you just have grams. So let's do that. The milliliters is this. So 238,896 milliliters times 0.790 grams per 1 milliliter, because the mass of 1 milliliter is that many grams. We can simply take 238,896, so 238,896 times 0.790. And it'll give that number, which we must turn to scientific notation. And round to how many sig figs? 3 sig figs, 3 sig figs. These other numbers we used, infinite sig figs, 3 sig figs. Okay, 3 sig figs it's going to be 1.89, because that 8 is next to a 7, it rounds up, times 10 to the 5th. And again, the mass is what we're looking for. Milliliter cancel milliliters to leave grams, so that's the mass in grams. All right, onward. Okay, onward. So this is how you go about the volume of a cube. I've already got it partially solved here. So 5 centimeters on all sides, cubic inches is your desired units. So the thing is, if you just, this times, the way you find a volume of a cube is side times side times side. So it's 5 times 5 times 5, but that would give you cubic centimeters, not cubic inches. So convert from from centimeters to inches first, because you have the conversion on the paper, and 1 inch is about 2.54 centimeters. So you set up your conversion factor with centimeters on bottom so we can cancel inches on top so that you can get inches. And then this is divided by 2.54 because 2.54 is on the bottom, and it gives this number. So you can manually type this times itself times itself times itself, or you can do it the quicker way. 5 divided by 2.54 gives that to the 3rd power. That's the same as this times itself times itself times itself, whatever, 3 times. And it gives this 7.62. Now with 3 sig figs and 3 sig figs, we better round to 3 sig figs. So we take this to the 3rd power, and it equals, let's round to 3 sig figs, 7.63 cubic inches. All right, onward. Now let's use our unit conversion skills here. Okay, so with this one, Canadian dollars could you purchase, or how many Canadian quarters could you purchase with 100.00 US dollars with that exchange rate? Okay, so there's our given, 100.00 US dollars. That actually is the standard abbreviation for US dollars. If you write out US dollars, it's fine. Either way, we got to do some conversions. How are we going to do this? We're going to go from US dollars. We got Canadian dollars for US dollars, so we're going to convert to Canadian dollars. That actually is the abbreviation for Canadian dollars right there. You can write it out or whatever. And then we can go from that to Canadian quarters. So let's do that. Let's put US dollars on bottom and Canadian dollars on top, because we have a conversion from Canadian dollars to US dollars. It's this right here. And then we're going to convert from Canadian dollars to quarters. So how is that going to work? Well, it says 1.303 Canadian dollars per US dollar. That means 1 US dollar is worth that many Canadian dollars. So 1 US dollar is 1.303 Canadian dollars. And then just like the US, we assume you all know that 1 Canadian dollar is worth 4 Canadian quarters. Just like 1 US dollar is worth 4 US quarters. So this is telling us we're going to take this times this times this. 100 times 1.303. Let me check the number. Okay. Well, actually, we'll just do one at a time just to avoid potential missteps. Times 4. And it gives you 521.2 quarters. Now, good luck having them chop a quarter into 5 pieces and giving you 0.2 quarters. So you're going to have enough money to buy 521 quarters and then have something left over. So I'm aware that technically 4 sig figs, 3 sig figs, or 4 sig figs, 5 sig figs, you'd round to infinite sig figs here, 4 sig figs, 5 sig figs, you call it 4 significant figures. I'm aware of that, but a little bit of common sense has to come into play here. You can't have a fraction of a quarter, so you're going to just get 521 quarters, and then, I don't know, someone's going to be losing something. All right, so 521 quarters. Now, here we go. Speed limit on a particular Canadian freeway is 80 kilometers an hour. An American tourist who doesn't know any better is driving 80 miles an hour. How fast in kilometers an hour are they going? Let's convert. So 80, we're trying to convert this to kilometers an hour. So we're trying to take this and express it as kilometers an hour. So let's start with 80 miles per 1 hour. Why did I write it that way? 80 miles per hour means you drive at a speed sufficient to travel 80 miles in 1 hour. So the 1 next to hours here is implied. Not that it doesn't change a whole lot, but nonetheless, it gives us something to work with. So we need to convert our units one at a time. Now, we have hours at the bottom for miles per hour. We're going to wind up with hours for the bottom for kilometers an hour. So really, all we need to do is convert miles to kilometers. And on the front side, you guys have that. This is the front side of the worksheet. You guys have that conversion. It says that 1 mile is 1.61 kilometers. So we can go straight from miles to kilometers. So put miles down here and kilometers up here. That way mile cancel mile, and you wind up with kilometers on top and hours on the bottom. So for kilometers per hour. It says 1 mile is approximately 1.61 kilometers. So that gives you something to work with. It's this times 1.61. So let's do it. 80 times 1.61 is 128.8. Now, technically, sorry, I wrote that out wrong. It's 80.0. So let's look at the numbers we started with. 80.0 miles an hour, that's 3 sig figs. This is 3 sig figs, so we better round this to 3 significant figures. So what is this rounded 3 sig figs? It becomes 129 kilometers per hour. Oh boy, is that tourist in trouble. All right, onward. The SR-71 Blackbird can reach speeds of 2,200 miles per hour. What is this in feet per second? We want to compare it with the speed of a 9mm pistol bullet, which is about 1,300 feet per second. So converting miles per hour to feet per second. 2,200 miles per 1 hour. And then we're going to take, how are we going to get to from miles to feet? Well, we can just go straight from miles to feet because it's on your reference sheet and it's also here. A mile is 5,280 feet. So we can convert from miles to feet easily. The hour on bottom, we need to convert that to seconds. So we need to go from hour to minute to second. So let's do that. It doesn't matter which one we do first. We could do this one first or this one first. I guess we'll do this one because I mentioned it. Mile on bottom and feet on top because we're going from miles to feet. That way mile cancel mile, leaving feet on top. That's what we want, feet per second. And then hour. We need to convert the hour. So put hour on top so that hour can cancel hour. And then we're converting from hours to minutes. So put minute on bottom. And then another conversion factor. Put minute on top so that minute can cancel minute so it's not in the final answer. And put seconds on bottom. That way seconds can be on bottom in your final answer. And then what we do is fill in the numbers. 1 mile is 5,280 feet. 1 hour is 60 minutes. 1 minute is 60 seconds. So we're going to take this number times this divided by this divided by this. Now to make it happen. 2,200 times 5,200, 80, divided by 60, divided by 60. 3,226.6 is whatever feet per second. So first of all, that's our raw answer. I'll write that down as our raw answer. 3,226.666 repeating feet per second. Now, obviously, we're going to have to make that scientific notation. So it's going to be 3.2 to whatever. How many sig figs here? That's 2 sig figs. Infinite sig figs because they're both English. Infinite sig figs because they're both time units. Infinite sig figs because they're both time units. So we're looking at just two significant figures. So that's going to become 3.2 times 10 to the what power? 1, 2, third. Third feet per second. Compare your answer to the velocity of a 9mm pistol bullet, which is 1,300 feet per second. Okay, so we're looking at, it's like something like 2.5 times as fast as a bullet. Faster than a bullet. So that plane's faster than a bullet. All right, finally, let's use unit analysis to figure out this question. During the First World War, the German military employed several gigantic long-range Paris gun cannons that were capable of firing a projectile to a distance of about 130 kilometers. It is known that the flight time of the shells fired from the origin to target was 182 seconds. Calculate the average speed of the projectile in miles per hour. So, okay, miles per hour. So that means we need to take the number of miles divided by the number of hours, because miles per hour, if you take the miles divided by the hours, you'll get units of miles per hour. So we need to convert kilometers to miles, and we have the conversion. We can just do that directly. We can take seconds, convert to minutes, and then convert to hours. So let's do that. Kilometers to miles. 130 kilometers times kilometer on bottom, mile on top. That way miles are a unit. 1 mile is 1.61 kilometers, roughly. This is approximate because of the different measuring systems. We won't round now, though. We'll round later. 130 divided by 1.61 is 80.745. 34. And there's more, but I'll just leave it there because there's no way we're going to need that many significant figures. As for the seconds to minutes to hours, that is going to be 182 seconds times, let's see, from seconds to minutes times from minutes to hours. So from seconds to 1 minute is 60 seconds and 1 hour is 60 minutes. So 182 seconds. 182 seconds divided by 60 is 0.05055555 repeating. So this is the number of miles, and this is the number of hours. So we can take this divided by this and get the answer. Alternatively, you can also just say, actually, no, sorry, yeah, this is the best way to do it. So we take 80.74534 miles. By the way, how many sig figs we're going to need? We're going to need about 3 sig figs because the numbers we started with had 3 sig figs. Our conversion factors had 3 sig figs or infinite. So it's going to be 3 sig figs. So that's why I did round, but I made sure it was more than 3. That way we have a little extra. 0.0505555 hours. And let's do that math. 80.74534. There are more decimals, but it doesn't really matter. Divided by 0.0505555, and you get approximately this much, roughly 1,597.1607 whatever miles per hour. Why do I say whatever? It's because if we're going to round to 3 sig figs, I wasn't very careful with the number of 5s here, and I didn't really care about the digits here because those might affect some of the decimals out here, but we're rounding way over here, so even if I was more careful, it wouldn't change our final answer. So 1,597 miles. We have 3 sig figs, and infinite 3 sig figs. So we're going to round to 3 significant figures. So let's go ahead and do that then. So first of all, our scientific notation is 1.5971607 and more stuff times 10 to the third miles per hour. say 1,597, yeah, it's roughly that. And then round to 3 significant figures. That's 1 point, okay, this is the third sig fig, it's next to a 7, so it rounds up. When this 9 goes up, it forces the 5 to go up also, so it becomes 1.60 times 10 to the third miles per hour as our average speed for the cannon shells fired out of the Paris gun. There we have it.